Strong statistics starts with strong basics. In this video we'll learn about basics of statistics. Statistics is the science of collecting, analyzing, and interpreting data to make informed decisions. Types of statistics. It includes descriptive statistics and inferential. Descriptive statistics summarize data. On the other hand, inferential statistics help you draw conclusions beyond the data. Population versus sample. Population is the entire group. Sample is a subset used to represent the population. Bias versus random error. Bias is systematic error, and random error is due to chance. Types of data. It includes qualitative data and quantitative data. Qualitative, also categorical, describes qualities or categories, like gender, blood group, disease present or absent. Quantitative or numerical, it is measured in numbers. Example: age, BP, weight, glucose levels. Measures of central tendency. People often say average, without realizing there are three different centers. Mean is average of all values and it is sensitive to extreme values. Median is the middle value and unaffected by extremes. Mode is the most frequent value that works even for categorical data. Measures of dispersion. Measures of dispersion describe how widely data values are spread around the center, mean or median. It includes range, variance, standard deviation. Range. Range is maximum value to minimum value and it gives a quick idea of spread. Variance measures how far each value is from the mean, on average, but in squared units. Standard deviation is the average distance of values from the mean. Low SD means data is consistent. High SD means data is scattered. Normal distribution is bell-shaped, where mean equals median equals mode, and most values are near the center. Example: adult height, lab values in healthy people. In non-normal distribution, the data is skewed left or right. Mean does not equal median, and extreme values present. Example: hospital stay duration, income. Parametric and non-parametric tests. Parametric tests are statistical tests that assume the data follows a normal distribution. It is used when data is numerical, data is normally distributed, variance is similar. Examples: Z-test, T-test and ANOVA tests. Non-parametric tests. Non-parametric tests do not assume normal distribution. They work with ranks or medians instead of means. Used when data is skewed. Data is ordinal. Normality assumptions fail. Examples: Mann-Whitney, Wilcoxon, Kruskal-Wallis tests. Hypothesis testing. Statistics works by challenging a default assumption. Null hypothesis H0 states that there is no difference, no effect, no association. Example: a new drug has no effect on blood pressure. Two treatments have the same mean outcome. Alternative hypothesis, H1 or HA. There is a difference, effect, or association. It represents what the researcher is trying to find evidence for. Example: the new drug changes blood pressure. One treatment is better or worse than the other. P-value and its significance. The p-value is a statistical measure that quantifies the degree of compatibility between the observed data and the null hypothesis H0. P is less than or equal to 0.05, we reject the null hypothesis. P greater than 0.05, we fail to reject the null hypothesis. In simple way, small p-value gives strong evidence. Big p-value gives weak evidence. Correlation versus causation. Correlation means two variables change together. When one changes, the other tends to change as well. It shows association, not influence. Causation implies a cause-effect relationship, where a change in one variable directly produces a change in another variable. Correlation describes relationships. Causation explains them. In pharmacy, correlation means two things occur together, such as more medications being linked with more side effects. This does not prove that a specific drug caused the effect. Causation is concluded only when evidence shows the drug directly produces the outcome. Evidence-based care starts with correct statistics. Next video will be on basics of statistical tests like Z-test, T-test and ANOVA tests. So stay tuned. Thanks for watching. Subscribe for more. Keep mastering. Keep learning only on Mastering Meds.